Well, good afternoon, folks. Welcome back to the Hilltop Workshop. On the bench today, I'm going to do a little bit of a show and tell. What I've got is a bunch of demonstration materials that was given out to B&W dealers for the 800 series, ever since the original Nautilus 800 series. So I'm going to go over a bit of a timeline of the evolution of different components. So I've got some bass driver material in front of me here, and I've also got, I've got a dedicated video to the tweeter and to the Midrange as well. I'll touch on them briefly. I do have one of the Continuum mid-range drivers here, but I've also got some crossovers, different bits of cabinetry and whatnot, and some other interesting things. So yeah, settle down, and I'll try to move through this as quickly as possible. So starting off, bass drivers. So bass driver material has evolved somewhat over the last 20-something years. This is the original Nautilus 800 bass driver cone, so it's a paper and Kevlar cone. Now, they used about 10% by weight Kevlar in the impregnation of the paper pulp, and they worked out that that was pretty much the optimum thing. Now, they weren't the first people to use paper with Kevlar impregnation in audio. Probably the first people to use it in domestic or domestic end user hi-fi, but it had been used in pro audio in the past and works very, very well. It makes it very strong, very rigid. It helps it to resist bending, and yeah, for the time and for that generation of speaker, it worked very, very well. So I think this driver here is probably going to be out of an 803, I think, an 803 bass driver, and of course they had the carbon fiber dust cap or brace that went over the top of it. It was designed to be the right, it was measured up and spec'd to the right diameter that was going to create the strongest amount of bracing wherever the driver needed it. So wherever they found this driver actually resonated the most, that's where they focused on putting that contact point for the carbon fiber dust cap. Now, it's not like your Dynaudios. It is actually connected to the piston, connected to the voice coil, so that dust cap was actually an integral part of the speaker and did actually become part of the driver. It wasn't just a cap. So you can see this this cylinder here actually would go back and contact and join up to the voice coil, making that one solid piston that would drive and be moved all together. So yeah, it worked very, very well. Just a poly rubber sort of butyl surround stuck onto the basket with an adhesive tape. And yeah, they were very reliable and worked very, very well for their time period. So that's out of the original Nautilus 800 series speakers. So all of your 804s through to 801s had that for their bass drivers. 805s obviously had the Kevlar mid-bass driver being just a two-way. So that was the first generation. Second generation, they moved into this stuff, which is their Rollercell. From memory, I think this came out in the 800S series, so your 804s through to 800S all had Rollercell bass drivers. Now, this is incredibly light. It's an expanded foam. It's used a lot in aircraft because it's very, very strong, very rigid, and weighs bugger all. And then on either side, they've got carbon fiber bonded to it as well, so it becomes extra stiff for a foam core. Now, they weren't the first to use Rollercell, not the only people to use Rollercell as a driver material, but they were the only people to use it in 8mm. Other manufacturers used Rollercell, but it was normally only about 1 or 2 millimeters thick, so B&W pretty much flew the flag for the thickest drivers, going with an 8mm Rollercell. But again, very solid, very, tiny little bit of flex. I don't want to snap it, but it's got a little bit of give, but it was exceptional and performed very, very well. It was a lot lighter than the paper Kevlar and a lot more rigid, so definitely a step forward. Most recently, they now use this material, which is called Aerofoil. It's a special foam core again. It can be done, made in varied thicknesses basically is the advantage of that over the Rollercell. So they can make it thicker where it needs to be, thinner where it doesn't need to be, so which of course makes it inherently lighter. Carbon fiber on both sides again, and even more rigid than the Rollercell, which made some of the most accurate and detailed bass ever. So very little coloration out of the Aerofoil bass drivers. Yes, where we are now is in a very good place as far as bass drivers go. It'll be interesting to see if they what their next step on bass drivers is, because hopefully they're not going to go to a metallic, because I'm not a big fan of them. That's the Aerofoil, and that's what's in Diamond series. So the 800D3 series has these. It works very, very nicely. We'll move on. Now, as I said earlier, I'm not going to go into too much detail about mid-ranges and tweeter drivers again, because I do have dedicated videos on those, but this is just another one of the industrial diamond tweeter diaphragms. I'm not going to take it out of this case because they're incredibly brittle. Because chances are I'll probably shatter it, and to replace, I mean, I probably wouldn't be able to get my hands on another one of these, but to replace, to give you an idea, to replace a tweeter driver on any Diamond series B&W, you're looking around about $1,500 Australian, so it's not a cheap exercise if someone sticks their finger through your tweeter. But yeah, that's a demonstrator diaphragm from a tweeter. This is the Continuum mid-range driver. First time they've moved away from Kevlar in the 800 series. It's just as flexible, if not perhaps a bit more flexible than the Kevlar, but it's a composite construction. The theory is that this is less susceptible to behavioral transitions. So the Kevlar, they found that it would get to particular frequencies and then it would behave quite differently. This stuff here is supposed to be a lot smoother. You can see, hopefully, maybe you can see there, it is actually semi-translucent, and it's meant to be markedly more improved in the openness and neutrality department. So no more phase cap on the no more phase plug in the middle. They've gone to a soft felt covered, I suppose you call it a dust cap, but it is attached to the driver. Still using the FST surround, so there is obviously a bit of movement in the spider, very little movement in the surround because it doesn't really have to. There's not a lot of excursion involved. Please don't have a hernia, as someone did in my other mid-range video about this, about me handling this and doing this and that to it. It's a demonstrator piece. So that is a Continuum cone, and that's what they've gone to in the more recent generation of the Diamond 800 series Diamond speakers. So the D3s all use the Continuum cones. So moving on to electronics, a couple of crossovers here in front of you. This crossover here is a mid-frequency crossover from an Nautilus 801. Air core inductors, capacitors and other components obviously made for B&W for this specific model, or for that generation of speakers. Big thick tracks on the back, good solid terminals. The wiring in this was actually made for B&W by Vandenhull. Silver coated copper, very decent gauge. You may or may not be able to see, it actually says Nautilus 800 series on the cable, so the cable was definitely not just off the shelf stuff. So this is an 804S, so this is the model or the series after this, and so that was a mid-range driver, a mid-range crossover. This is the mid-range crossover out of the 804S, so this was 801, then there was 802, 803, then the 804, so this is quite a few rankings down the chain, but in the newer generation, so you can see how much more serious they got as far as their components got. So big, air core inductor with a plastic former on it, obviously. Components that are labelled and generated and manufactured for B&W. On the back, you can see, in contrast to the earlier generation, they've just, gone with a basic form. Here, they've basically filled out and used every spare section, every spare square centimetre of the PCB for track, and then just carved out minimal separation between the two of them. So they've kept as much conductor on the PCB as they possibly could. Yeah, quite a move forward, considering that, that was their flagship mid-range crossover, and this was the second from the bottom. So the smaller of the floor standers had this size crossover for the same driver, for the mid-range driver. So fairly substantial advancements came in just that initial phase. Speaker terminals were WBT. I'd have to check and confirm what they're using now. They've changed the terminals substantially. They've gone to an all-metal terminal now with a round thumb. I'm not a big fan of them, to be honest. WBT terminals are everywhere. They're ubiquitous in hi-fi. They're a good terminal, a good quality terminal. The only complaint I have about these ones is that when you put a spade terminal in there and you go to clamp it down, there's two separate pieces to this clamping nut. So there's the nut that spins around, then there's a separate compression face or compression part there that actually squeezes against it. So the idea is it can stay stationary while you tighten the nut down, but that didn't always happen. And the thread was not super coarse, but it wasn't fine enough in that it would want to clamp down. You'd really have to put a serious amount of hurt on here to be able to get a decent amount of clamp. A finer thread would have been nicer, or perhaps, you know, having something with a bit more grip so you could put a bit more hurt on the cable would have been better again. You can stick a banana plug in the back, banana plug or a bare wire on the side, or spade terminal or bare wire in the side there. They did the job, but again, yeah, my only complaint with these was using a transparent cable or something like that with a big, relatively heavy conductor and a big fat spade terminal to get them to clamp down and know and feel confident that you had, a maximal area of contact between the terminal and that spade terminal was kind of hard to achieve. So I'm always a fan of bare wires wherever I can, but if you're using pre-made cables, they're going to come with spades or bananas anyway, so you can't really do too much about that. So all WBT terminals on a proprietary designed, I suppose, mounting plate to put in the back, and this would always be down at the base of the speaker. Pretty sure they used the same ones throughout the entire range, all the way from the Nautilus 800 Nautilus 801s all the way down to the 805s. They used the same componentry. So, yeah, all the way through the range, same. So just going to touch on some cabinet construction materials. This here is the flow port. So this was used in the original Nautilus 800s again. And they've continued to use a similar sort of design right throughout the range. They've made some different improvements and changes on it, but the idea behind this was, of course, there'd be a tuned length section on the back here, depending on the model of the speaker. But the idea with these dimples was that they took the theory from a golf ball surface, basically, to smooth and silence the airflow through the port. Chuffing from ports does exist, I've heard it. Some of you probably haven't, but specific speakers that are, a bit more primitive or a bit older in their design, you can actually hear at particular frequencies the air rushing in and out and around the different formations of the port, and it can be a bit distracting. Some subwoofers are really, really good for it, but also some decent-sized floor-standing speakers that don't have a properly or, an advanced style of port. You will actually hear that chuffing of the port. So this did appear to eliminate that. I've had plenty of experience over the years with everything from the 805s up to 800s. I've played all manner of things into them to try and get them to misbehave one way or another, and chuffing is one thing that I've never heard from a Nautilus or an 800 series B&W. So looks nice at the very least. Well, I think so. This stuff here is called Isopath, often confused or compared to sorbethane. So it's a very, very squishy and impact-absorbing material. It was made by Raychem. This little section here goes between the turbine head, the mid-range driver that's on the top of the 800 series speakers, so more the flagship ones, so your 802s, 801s, 800s. Between that and the timber cabinet, that's where you'll find this. So this goes on top onto the timber. Then there's a big lug on the base of the turbine head that goes through there. There's a nut that goes on the bolt that comes through and a nut that goes on the bottom of that, and it's tensioned at the factory. It doesn't get pulled down tight. I'm not suggesting you go and do this, but if you were to grab the turbine head of 800 series B&W, you'd find that it does wriggle around a bit. And so they've worked out, obviously, the right amount of tension and the right amount of hurt to put on this that's going to keep it clamped down onto the cabinet and not wobble around, but also not going to transfer any vibrations or any coloration from either cabinet to the other. So very, very nice material. Very, very shock absorbent. It does a great job of doing that. Squishy, fun to play with. So I'm just going to cover a bit of cabinetry material now. So I've got a few different samples here. I'll go through these shortly. Start with this stuff here. This material is called Marlan. This is what the turbine head is made out of. Now, in the turbine, in the formation of the turbine, it can be anywhere from, I think, 10 to about 60 mil thick. It's bloody heavy. It's very dense. Initially, it was made for like kitchen and bathroom bench tops. It's that sort of a composite, so it's very, very solid and worked very well in the turbine heads. And to my knowledge, that's still the same material that they're using now. It's not cheap. It's not light. It does resonate a bit. But I'm told that the thicknesses that they use throughout the housing are chosen and formed and selected to be able to eliminate any resonance through any particular frequency. So anywhere they found resonance, they made it thicker and thinner so they could do away with that. So that's that material. And here we have some cross-sectional cuts of timber that they use for the cabinetry of the speakers. Now, these pieces here are all from an 801, a Nautilus 801, so first generation of the Nautilus 800 speakers. These ones here, the laminations are beechwood laminated, and then they had a red cherry and a natural cherry stain. Anything that you saw in black was all MDF. These other ones are actually laminated timber. The black ones were not done in laminate purely for the fact that you wouldn't see the laminations. So the black ones they just made in MDF. Now, there was the controversy, or in the beginning there was the question getting thrown around, okay, well, if the black ones are made in MDF and the cherry wood finished are made in beech, then isn't there going to be a difference in the timbre of the cabinet? B&W's answer to that was categorically no, and it stands to reason that the cabinetry, when it's this sort of thickness, is that dense, and with the amount of matrix bracing that they put in these speaker cabinets, they're virtually non-resonant as it is. They're virtually as dead and colourless as they possibly could be, so that was pretty much negligible, at least in their marketing. But I would challenge anybody to do the Pepsi challenge of sit down and do a double-blind test with an MDF Nautilus speaker versus 800 series speaker versus a beechwood laminate, and try to tell the difference. I don't think that's going to be a realistic thing for anybody to be able to do. Interesting point as well is that the laminated timbers were only used in 802s and 801s. So 803s, 804s, 805s, the only place they used, they were all MDF cabinets. The only place they used laminate was on the top face, where the cutout is for the tweeter. So they could get that laminated impression or laminated look in the cutout with the tweeter nests. So anything 805 through 803, all MDF cabinetry. And 802s, 801s, and 800s, that's where they used the laminate all the way through the construction in the cherry wood finish, in the natural cherry and the red cherry. And as I said, anything else in black was all MDF. Now, coming up to more modern construction, this is a cutaway of the Reversewrap cabinets that they're using in the current, was the current 803 D3s or 800 series D3s. So every cabinet in the range now is laminated. It's a very, very serious cabinet. So the whole cabinet, there's no flat sides to it at all. Even the front is curved. The rear is flat, but it's aluminium. Again, with the colours, they are a stained finish. The black that you see, any of the piano black ones, are ones where they've had imperfect grains or imperfect matches between grains. So anything that's not going to give a perfect finish through a stain, they paint piano black. But the construction through them all now is this Reversewrap multi-layer construction, which provides the stiffest cabinet that B&W has ever produced. So that's where we're at the moment. All multi-layered laminate through the 800 series. So that's all I've got as far as B&W 800 series stuff goes. Like I said, I've got separate videos on the tweeter and the midrange. You can look at those whenever you like. They'll be in my playlist somewhere. But I hope you found that interesting. As I said, it's just a bit of a run-through of the evolution of different products and different components through the ranges. So bass drivers, crossovers, cabinet materials, and whatnot. So in the meantime, I hope you've enjoyed the video, and look forward to catching you in the next one. Any questions or whatever, just feel free to leave a comment in the comment section, and I'm happy to engage in some interesting dialogue if there tends to be any. Otherwise, thanks for watching, and I'll see you again soon. Cheers.